Is finding your dream career feeling impossible right now? You're not alone. Welcome to Career Blueprint, the podcast that helps you figure out your next career move. We explore the trends in tech shaking up the job market, giving you the unfiltered advice you need, whether you're starting out, changing direction, or guiding someone else. Let's figure out what's next for you together. This is Career Blueprint. Our fourth type of AI technology we're going to talk about is computer vision. The original idea behind computer vision also began in the, you guessed it, 1950s, when researchers started experimenting with getting computers to interpret shapes and images. The early work in computer vision overlaps with the development of deep learning and the initial neural network models, which focused on pattern recognition. It turns out that human vision and sight is extremely hard to replicate. It took decades for computer vision to be anything other than a fun experiment in a computer lab. Think back to the 50s and 60s and think about the technology we had at the time. Cameras were still pretty rudimentary and basic. So the idea of computer vision didn't really get going until the 80s, when scientists were able to get computers to understand three-dimensional space and edge detection, where an image starts and stops. Computer vision started to become a commercially viable product towards the end of the 1990s and early 2000, when computer facial recognition became possible and computer processing speeds were finally fast enough to analyze videos real time. Today, computer vision is what powers facial recognitions on smartphones and computers. It enables medical imaging and automated checkout at stores, and it helps us tag someone on social media. There are still limits on the accuracy and usability of computer vision. It can be very accurate when identifying objects or reading labels, but it's not always reliable in unusual lighting, crowded scenes, or with images that differ a lot from the ones it was trained on. So for now, computer vision is impacting some jobs that involve visual perception, pattern recognition, and routine manual assessment tasks. So think of jobs like a retail cashier, store security personnel, photo editors, manufacturing quality control inspectors. But as we'll talk about in future episodes, this is an area where the technology still needs development. Our fifth and second to last AI technology we'll talk about today is robotics. Now, the idea of robots has been around for a super long time. Leonardo da Vinci sketched designs for a humanoid robot during the Renaissance. So robots are something that humans have been fascinated with for hundreds of years, but their development has been a slow-moving train. Modern commercially viable industrial robots were first launched in the 60s. One of the first commercial robots was called Unimate. It was nothing like we envision robots today. It was just a huge, heavy arm connected to a big computer-like box. It was first commercially used by General Motors, a car company, in 1961, and its task was pretty simple. It would move hot, heavy metal car parts, the parts were die castings, and then it would weld those parts onto car bodies. Now, all of that sounds really basic to us now, but this was groundbreaking at the time. And it was an important development for humans because it took over hazardous, monotonous work that humans didn't really want to do. Unimate changed people's perceptions of what robots could do, and it sparked the beginning of modern industrial automation. Today, there are millions of robots on factory floors doing all sorts of tasks. Robots slice and dice food, they assemble toys and medical devices, they check stock levels on store shelves, they even assist with surgeries. Now, robotics have dramatically advanced since Unimate, but today there's still many tasks robots just can't do. Robots aren't good at handling and manipulating objects. They particularly struggle with soft, irregularly shaped, or delicate objects. Think about a robot trying to give you a really good massage, trying to fold laundry, pick up a single egg from a pile and move it. Robots also don't do well in unstructured environments. They excel in predictable, controlled spaces like a factory line, but they don't do as well without physical boundaries. This is one of the reasons why automated cars are taking a while to be developed, and why we keep seeing those funny videos of Waymo taxis honking at each other in a parking lot. And most importantly, robots have historically not been able to handle complex human interactions. They can't resolve conflicts or negotiate a contract or handle an unhappy customer. And they've not been able to do creative or artistic work. Now, scientists and technologists are really excited about the possibilities of pairing robots with deep learning and natural language processing. But it's going to take time. We're not to the level of Battlestar Galactica yet. Don't worry. It's going to take time. The last AI technology we'll talk about today is the technology that is disrupting jobs and classrooms the most right now. And that technology is called Generative AI. ChatGPT is a generative AI chatbot. Generative AI is a combination of several forms of AI, including machine learning, deep learning, and natural language processing. It's the creative cousin in the AI family. Generative AI started as an offshoot of deep learning, which, as we talked about, is modeled after the human brain's ability to find patterns in complex data. As researchers explored new ways to apply these deep learning models, they discovered innovative approaches for creative content generation. A major breakthrough came in 2014 when scientists invented a technique called generative adversarial networks, or GANs. GANs were essentially two AIs in a friendly competition, one trying to create something new, like a fake photo, and the other trying to spot the fakes. The two AIs interacted with each other, going back and forth, until a close-to-real final product was reached. This GANs approach led to huge breakthroughs. Suddenly, AI could create photorealistic faces, original artwork, and even music or videos that felt remarkably authentic. Fast forward to today, and generative AI is everywhere. It can write stories, craft marketing copy, answer emails, generate art. It can even create software code. But the content it creates is not perfect. For example, generative AI is great at providing a first draft of a document, but it's not as great at providing a finished, final, ready-to-use product. It's not especially creative or original. It has limited critical thinking ability and emotional intelligence. And it's prone to bias and hallucinations. We do not yet know generative AI's full potential, but experts are predicting that it will be an incredibly powerful productivity tool for busy experts. For now, experts aren't predicting that generative AI will eliminate entire categories of jobs. It's not quite that. Instead, they are predicting it will make the people who use it so much more productive that companies simply won't need to hire as many employees to get the same work done. That's a subtle distinction, but a very meaningful one. Creative roles will still exist, but those opportunities will go to people who not only bring their talents to the table, but who also know how to harness generative AI to enhance what they do best. Thank you for joining me today on Career Blueprint. We had a lot of tech talk today, and I appreciate you staying until the end. If you missed something or want more information, don't worry. We'll go over these concepts again as we do deep dives in future episodes. But I thought you might want to have a shared foundational understanding of AI before we started our conversations together. If you have a minute, I would love to hear from you. Leave me a comment, a question. Follow me on social media. I'd love to get to know you. And I'll see you next time on our next episode when we talk about how ambient listening AI technology is changing jobs in the healthcare industry.